Right, this next section, we are going to be verifying trigonomic identities. So the nice thing about this section is that it is similar to simplifying. The only difference is that we actually know where we want to end this time. So when we are verifying, we are going to take the more complicated side of the equation and we are going to simplify it to the simpler expression. So if we're looking at this first problem, this is more complicated. So I'm going to just work through simplifying this, kind of ignoring the fact that this is here until I get to the step where I see this. Okay. So if we get started here, now we're still using all of our same rules that we did in that last section. So we're focusing on our reciprocal, quotient, and Pythagorean identities. So again, I am going to work on simplifying this part right there. So I'm going to choose to start with this first term. And I'm going to substitute in the quotient for the cotangent. So this is going to become sine theta. And again, whenever I have fractions and fractions, I always make the original fraction bar a little more bolded so I remember where it's at. And then cotangent will become cosine theta over sine theta. And I am going to just leave this alone for right now and see what this simplifies to. So this will still be minus secant theta. Right now, I don't want to divide by the fraction, so instead I'm going to multiply by the reciprocal. So I'm going to have sine theta times, and then sine theta over cosine theta, still minus the secant theta. Now if I simplify that by multiplying straight across, that will become sine squared theta over cosine theta. And now I'm going to choose to use the reciprocal of this one. So we're going to minus 1 over cosine theta. Okay. Now that worked out nicely for me because I have the same denominator. And whenever we have more than one term, remember we want to try and get it down to a single term, especially if this side is a single term. And since my denominators are the same, I'm allowed to think of this as one big fraction. So this will be sine squared theta minus 1 over cosine theta. Okay. And looking at that, that reminds me of a Pythagorean identity. So it's not exactly the same. So I'm going to use this one. And I'm going to do some work off to the side to rearrange that. So the original is that cosine squared theta plus sine squared theta equals 1. And I want to make this look like my numerator. So to do that, it looks like I need to subtract the 1 over. And I want this to stay with that 1. So at the same time, I'm also going to subtract cosine squared theta over. Okay, so that means that this is going to become sine squared theta minus 1 equals negative cosine squared theta. Okay, so this part matches my numerator. So now I'm allowed to replace that numerator with negative cosine squared theta. So that's going to be my next step. So negative cosine squared theta over cosine theta. And then we can simplify that. So I can simplify the cosine in the denominator and then one of the cosines in the numerator. And I will be left with negative cosine theta, which matches this part right here that we were trying to find. So I just verified that these two things are equal, which makes them an identity. Okay. All right, let's try another one. All right, so again, we are going to start with the more complicated side. So again, we're going to be focusing on this side. So I'm just going to pretend that my secant isn't there for right now, and I'm just going to focus on simplifying this as much as I can until I get to this, and then I know I'm done. So again, I'm going to start with the tangent, and I'm going to rewrite that using its quotient. So that will be sine theta over cosine theta. And at the same time, I'm also going to use the reciprocal of the cosecant. So this will be 1 over sine theta, and then plus cosine theta. And this term, again, I don't want to divide by the fraction. I'm going to multiply by the reciprocal of that denominator. So we will have sine theta divided by cosine theta times the reciprocal, which is going to be sine theta over 1, and then plus cosine theta. Now I can't cross reduce anything, but I can multiply straight across. So this will be sine squared theta over cosine theta, and then plus cosine theta. Now again, when we have two terms, we want to try to get them down to one term. So I need to think of this as over 1, and then I need a common denominator. So my common denominator is going to be this cosine theta, so I'm going to multiply the denominator and the numerator by cosine theta to get this term to have the same denominator. Okay. So that means that this part will stay the same, so sine squared theta over cosine theta. And then when I multiply, this will be plus cosine squared theta over cosine theta. Okay. Right, so now that my denominators are the same, we can think of it as one fraction. So sine squared theta plus cosine squared theta all over cosine theta. And looking at that, that gives me a Pythagorean identity. So that's this. So that means that I can replace the numerator with 1. So this will be 1 over cosine theta. And then I can use my reciprocal rule to rewrite this as secant theta. Okay. Now notice how I have this term right here. So I just verified the identity.